My name is Richard Deaves, Professor Emeritus of Finance, DeGroote School of Business, McMaster University. My area of expertise is behavioral finance, and I have taught a course in this field for quite a few years. Using a set of PowerPoint presentations, I plan to give interested listeners a short course in behavioral finance. Naturally enough, I begin with this introduction. This introduction will be followed by 5 lectures, each with a Part A and a Part B. All of these PowerPoints are based on a course that I've taught over the years in behavioral finance, primarily at McMaster University, but also at various universities on multiple continents. There is also a course book that follows these slides, and I'll tell you more about the availability of that later on. At the end of this intro, I will preview the 5 upcoming lectures. Let's begin. So the field is called behavioral finance. There's 2 words here, behavioral, why behavioral, and finance, how is it finance? Let's start with the second word. Well, finance is a branch of economics. It's all about, like economics, it's all about optimization, doing the best you can, subject to constraints. And it's normally assumed that decisions that are made by various decision makers are grounded in rationality. And the stress in finance, 2 main stresses. One is intertemporal choice. So we could, for example, consume today or consume next period. And it's also about how much to save in the future. And another important choice in finance is the risk versus return choice. How much risk are we comfortable to take on? The other word is behavioral. Why do we use the word behavioral? Because in behavioral finance, we're looking at actual behavior. Economic analysis often assumes that this behavior is irrational. Is that true? Is real behavior always irrational? The answer is there's a lot of evidence that suggests behavior is sometimes not rational. And I'll get to examples of that in a moment. But first, let's talk about the basic economic paradigm, sometimes called neoclassical economics or conventional economics, and what's behind it, what's being assumed by this approach. Well, it's assumed that people, individuals, maximize utility, satisfaction, or happiness, and that firms maximize the value of their stock, and that they're acting in the best interests of the owners of the firm. So decision makers, or DMers for short, have rational preferences when making consumption or investment choices, and there's no bias. They're using all the information at their disposal, and decisions are unbiased. Another assumption that's generally made is that people think about themselves or perhaps their immediate families. So other regarding preferences, in other words, altruism towards your fellow man, people that aren't related to you, that is normally assumed away by conventional economics, despite the fact that, of course, many people do behave in an altruistic fashion. So I'm going to circle an important word here, preferences. Okay, the assumption is that people have rational preferences. And we're going to talk about utility maximization, which, of course, has preferences front and center. So utility maximization. The idea is that we have some income, we have some wealth, and we want to decide how to spend it to make us as happy, to give us as much satisfaction as possible. So it's framed in the following way. A decision maker, a consumer, maximizes utility over a number of possible inputs. These inputs are goods and services that can be purchased and consumed. And of course, people do have limitations. The limitation is how much wealth you have. Let's just think about your income at a particular point in time, which is M, and P is the price of some product, and X is the quantity consumed. So P1 times X1 is total spending on good or product number 1. And the same with 2 and 3 and so on. And assuming there's N products, if we take all of those products, here I mean product in the sense of P times X, then we get total spending. So total spending cannot exceed your income. That's where this particular constraint comes in. Preferences, of course, show up in terms of the utility function. People will have different utility functions. So what are some of the assumptions that are made about these utility functions, and how do they relate to rationality? One fairly obvious assumption is called non-satiation. In other words, the more the better. People want more cars, they want more houses potentially. Maybe you want to have a vacation home and then a home in London, another one in New York. Well, of course, not feasible for most people, but you would like it if at all possible. Non-satiation. The more the better. We also tend to assume transitivity of preferences. So what does that mean? Let's say I prefer lemon gelato to chocolate gelato, and I prefer chocolate gelato to strawberry gelato. Well, if those are my preferences, nothing wrong with those preferences, then wouldn't it be strange if I preferred strawberry gelato to lemon gelato? So look at it. Lemon is preferred to chocolate. Chocolate is preferred to strawberry. So it seems that strawberry should be at the bottom of the preference order. So to flip-flop things and say I prefer strawberry to lemon would be quite odd. So in order for preferences to be in some sense reasonable or tractable, the assumption of transitivity is an important one, and it's commonly made. So let me talk about utility maximization. Let's take an example. Say there's two goods, bread, which is loosely food, and water, which is loosely refreshment. And the units are B and W, loaves of bread, say, and liters of water, say. And say the price is PB and the price of water is PW. Income is M. So the optimization problem is maximize your consumption, or maximize your utility, I should say, over your consumption of B and W. And of course, you can't spend more than you have. Borrowing is not part of this simple model. So we are subject to the budget constraint where M is equal to all of our spending. So here is a standard graph from microeconomics. On the x-axis, we have B, which is units of bread. On the y-axis, we have W, which is units of water. And the straight line connecting the two axes is the budget line. And the intercepts are as follows. The y-intercept is M over PW, very simple to see that. And the x-intercept is M over PB. Those intercepts are based on spending all your money on either one good or the other good. And we have indifference curves as well. An indifference curve is a trade-off between the two goods, W and B, and as you move up or down the indifference curve, you get either more B or less B. If you get more B, you give up W, and the opposite holds as well. But the main point is, along an indifference curve, you're not better off, you're not worse off, you're indifferent as you change your consumption bundle. So notice that particular indifference curve is just tangent to the budget line. There's other indifference curves that, for simplicity, I don't show on this diagram. The one I do show is tangent to the budget line. And the tangency is at that particular point, which I've pointed to. At this point, utility is maximized subject to our budget constraint. And B star and W star, those are the amounts consumed at the optimal point. So we've been talking about preferences, but in finance, we're concerned with somewhat different preferences. We don't care too much about particular goods and services purchased and consumed, but instead we focus on two kinds of preferences: time preferences and risk preferences. First, risk preferences. People don't normally like to be taking on risk if it's not rewarded. But how do we quantify this particular human tendency, the need to be rewarded for taking on risk? By the way, at the level of the market, this will come out in the so-called risk premium. The fact is that risk premiums are positive. There's also time preference. People prefer to have money sooner rather than later, but once again, how do we quantify this? And at the level of the market, this will come out in the fact that normally interest rates are positive. So it's all about trade-offs. A trade-off means we have to give something up to get something. What are the trade-offs? So what are the trade-offs in finance? The trade-offs in microeconomics are over two or more goods and services, but instead we take a different perspective in finance. There's really two main sets of trade-offs. First, in the realm of time preference, we can either consume now or consume later. So if we consume now, we need to spend a lot of our money now, but we have to borrow against perhaps future income, so we'll consume less later. The inputs are money and consumption at different points in time. In the realm of risk preference, there's also a trade-off. The trade-off is between risk and return. So risk is a bad thing. People don't want to expose themselves to risk needlessly, but if they take on this bad thing, risk, on average they can get a higher return on their investments. So the trade-off is in terms of higher expected return versus higher risk. SD stands for standard deviation. So we're talking about behavioral finance. I've already mentioned the idea that behavior may not be rational. So is behavior rational? Not always. I'm going to give an example from the realm of golf. There we have a very famous golfer, Tiger Woods. He's on the green. He's about to putt. For those not really too knowledgeable about golf, a putt is potentially the last shot you make. You might need to make 2 or 3 putts, but it's when you're very close to the hole and you're about to finish off the hole. You need to minimize the number of strokes to get the ball into the hole. So does Tiger Woods have a higher probability of making a birdie putt or an equivalent par putt? So a par is what a good golfer expects to get on a hole, and a birdie is what is a 1-stroke improvement over what a good golfer expects to get on a hole. Does Tiger Woods have a higher probability of making a birdie putt or an equivalent par putt? And why do we care about this? This, after all, is behavioral finance. Does the behavior of Tiger Woods have anything to say about financial decision making or about what happens in financial markets? And amazingly, the answer is yes. But for now, let's just focus on the golf part. Let's think about the probability of putting success using Tiger Woods as an example. Very interesting study looked at between 2 and 3 million golf putts attempted by professional golfers on the PGA Tour, 239 tournaments during a 6-year period. Very detailed study, success or failure on a putt plus exact to the inch location of the ball on the green relative to the hole or the flag prior to the attempt. Most putts, by the way, were for par. A few less in percentage terms were for birdie, 47% versus 40%. Of course, those don't add up to 100%. Some putts were for eagle, which is even better than birdie. Some putts were for bogey, which is worse than par. And other possibilities are also true as well. How one performs on a particular hole, taken in isolation, doesn't really matter. What matters is your cumulative performance over an entire round, but in the case of a golf tournament, over 4 rounds. 4 rounds means 18 holes times 4, 72 holes. So given that, it's logical that equal effort should be expended on all shots. They all matter just the same. Is that what happened? Well, turned out, very interesting result, it turned out that holding everything else equal, and this was a very careful study, so let's assume that they succeeded in holding everything else equal, it turned out that pars were sunk less, or I should say pars were sunk more often by about 2%. So let me repeat myself, pars were sunk 2% more often than birdies, holding everything else equal. So a 6-foot birdie putt, 6-foot par putt, exact same location, people tended to sink the par putt 2% more often. So what on earth is going on? Well, it turns out to be related to something called loss aversion. A theory known as prospect theory, which I'll get to later in these slides, next lecture in fact, says that people hate to lose. The disutility, the unhappiness of, say, losing $1, forget golf for a moment, the unhappiness of losing $1 is much higher than the happiness or the utility of making $1. This is called loss aversion. People hate to lose. But losses and gains are often relative to what you expect. Now, back to golf. For professional golfers, the benchmark is a par. They expect to make a par. If they get a birdie, great, they're very happy. If they get a bogey, which is worse than par, they're quite unhappy. A par is what they expect. So because of that, and because of the fact that golfers hate to lose, more effort is probably expended to avoid the dreaded bogey by most golfers. And that's really what this study is showing us, the power of loss aversion. It turned out that 94% of all professional golfers displayed this kind of behavior. And Tiger Woods was indeed one of these professional golfers. So prospect theory, and that's something that's very important, and we will be getting back to it. And loss aversion, we'll be getting back to that as well. The idea there is that people hate to lose. So this research is really saying that rationality is sometimes lacking. Is it really rational to fixate on losses? And the answer is no, not really. In the context of golf, you should look at the big picture. Don't fixate too much on a particular hole, a particular shot. Shouldn't we consciously make the best decisions possible? Isn't that the way it should be? Well, there's research called priming research that suggests that sometimes decisions are not even consciously made. So if they're not even being consciously made, how can we consciously make the best decisions possible? And I'm going to give you a couple of examples. So take a look at that picture. Would just looking at a $50 bill, Canadian in this case, would just looking at a $50 bill influence your behavior? And of course, the answer seems to be, that's ridiculous. How would that influence my behavior? Well, it turns out that priming research says that when people merely look at money, such as looking at that picture, they tend to act more independently, they tend to act more selfishly, and they tend to exhibit greater individualism. What's going on there? Money has acted as a prime. It somehow triggered in people's minds the feeling that they want to act more independently, they want to be more selfish, and they want to act more individualistically. Priming research then shows that mere exposure to a word, an idea, or an image can influence behavior. And this is all done outside of conscious thought. Here's a few more examples that are somewhat entertaining. It turns out in one psychological study, the researchers got people to nod, and then they made various statements, and they asked the subjects whether or not they believed the statements, and it turned out that nodding actually gets people to believe the statements. It induces credence. And shaking the head does the opposite. It tends to induce skepticism. There's a lady with a pencil in her mouth. Why is she doing that? Well, another study shows that people who hold a pencil in their mouth sideways, the way this lady is holding the pencil in her mouth, that forces the facial muscles to create a smile. So who cares? Does that really matter? Well, turns out they find jokes funnier. So the prime of having a forced smile leads the person to think that the jokes are actually funnier. By the way, let's hope that in this world of COVID-19, that pencil has been properly sanitized. Looking ahead, in lecture 1, I'm going to discuss preferences. So the key preferences in finance are risk preferences and time preferences. And in lecture 2, I'm going to talk about various psychological tendencies that are important for understanding behavioral finance. And with lectures 1 and 2 as my building blocks, I'll then turn to investor behavior in lecture 3. After lecture 3, I'm going to move to market outcomes in lectures 4 and 5. 4 deals with market efficiency. Are markets efficient? And I'll talk about what that actually means when I get to lecture 4. And if there are inefficiencies, and these are called anomalies in many cases, or just plain puzzles, are there behavioral stories that explain these anomalies or puzzles?